Very good evening, everyone. Can you guys hear and see me? Let me know in the chat. Can you guys hear and see me? Thank you, Navneet. Thank you, Anand, for confirming how you guys are doing. Hello, Arad. So it was long, I would say long vacation or long weekdays. We haven't met. Same from my side. It's like, yeah. So how was the Dasara for you guys, or whatever festival you guys are celebrating in your region? I'm sure like in India, in different regions, we were celebrating different festival at the same day. So what about you guys? You guys was enjoying? Didn't do anything? Oh, so you were practicing? Then I can understand you were practicing, right, Arat? That's good. That's also good. That's also next level of enjoyment, right? So what about others? Anand, Navneet, what about you guys? Yes, enjoyed the Sarah. Oh, nice, nice. Yeah. Actually, in my place, it was raining. So, enjoyed not like I have not enjoyed that much. But yes, at the end, like I have visited the place where all the fair was going on, saw some of the scenes. But yeah, raining has changed everything. Today also it's raining, so I have not turned on my fan or AC, nothing. Just sitting like that. Okay, so that's all about the other stuff. What about the link list, guys? I know you guys got a lot of content to lot of time to go about the link list. So I'm just confused a bit in circular link list. Ah, that's okay. That bit of confusion is fine. We should have that bit of confusion in everything. Otherwise, we will not revise it. So that's okay. We will just go through that doubt today or to tomorrow's revision class. Anytime we can discuss about it. Okay, Rad? And today actually we are going to see a lot of problems. Whatever we have learned in linked list, all the basic things, right? We have learned about node. We have learned about how to create a nodes. What are the properties a node has in linked list, right? And if you want to traverse, how we will be traversing it, how we will finding the end of any of linked list. We have gone all those things, right? These are the basic things. We all should know about the properties of node, properties of any linked list node, which is what are the properties of any linked list node? If I am talking about a single linked list node, yes, Nilanjan. So tell me, what are the properties? If I'm talking about the single linked list node, what are the properties? Everyone, everyone, tell me. I'm talking about single linked list, value and next, right? Yes, value and next pointer. Totally right. Yeah. Okay. Now tell me, if I want to start a linked list, what are the pointer which any every linked list provides? If I want to start a linked list, what is the pointer every linked list provides? Everyone answer. I'm talking about the start point. Anand, Arad, I'm only talking about the start point. Yes, everyone is saying head, right? So this is the start point from where every linked list has to start. Okay, now let's talk about how can we identify where our linked list is ending. There are two ways to identify it. I want to know both ways. You just write in the chat both ways. Okay, sure. Let me repeat it question. So, how can we understand our linked list is going to end? How can we understand our linked list is going to end? And let me give one more constraint. And if we do not have tail, if we do not have tail pointer with our linked list, how can we understand or how can we identify that our linked list is ending? Everyone tell me. The question is, let me repeat it. Let me repeat the question, guys. How can we identify our linked list is ending? And we have not provided tail pointer. Two things. We have not provided tail pointer in our linked list. Now, how can we identify that our linked list is ending? Everyone now answer it. Divikant, your answer is wrong. So Arad, if tail dot next is equal to null, I'm saying tail is if the tail is not there. Nilanjan saying when pointer is pointing to null, that will be tail or end. Okay. We can traverse all way, and when we get null, it's end. Okay. In case of circular linked list, if I'm talking about single linked list, Vishal. Node is pointing to itself. Let's talk about the single linked list only. Node dot next is equal to null. Yes, Anand has given perfectly answer. Node dot next is equal to null. He has to just write one more thing in that. We will be traversing whole nodes, and when we got node dot next is equal to null, that would be the last node. That would be the ending. If value is null, that's not right. Divikanta, if value is null, it means you are saying a linked list node has two properties, value and next. So it means you are saying value part is null, which is not correct. If any of the nodes next is null, that's the endpoint. Okay, Nilanjan, without tail pointer, tail can't be identified. No, we can identify the tail. Wherever in a linked list, wherever any node, any node's next is pointing to null, that is our tail element. Okay, sure. Okay, so guys, these three things are important only. These three things are only important to understand the single linked list. One, from where we have to start. Second thing, where we have to end. And third thing, what are the properties any linked list node has. These three things are important. If you know about these three things, if you can visualize these three things, there is nothing more to learn about linked list. Now we will see today lot of questions on these three basics. Now we'll see today lot of variations of questions on these linked list topic. Okay, but before moving further, I remember the Reliable wants me to look for the assignment question, right? So let me share my screen and let's look into the assignment questions for the linked list one. Like whatever we have completed, let's look into that and then we can jump into today's topic. Okay, guys? So while talking about the linked list today, so everyone visualize the linked list. At the start of everyone, create a linked list in your mind, like 3 or 4 elements. Put the head pointer on the first node, right? And at the end, if you do not want to put tail, that's fine. Just you should know that last element should point to null. Okay, that's the visualization you should have. And let's now look into first the queries or the assignment part of the first one. Okay, this is the first slide, right? You guys can see my screen. Yeah, great. So let's answer first question here. So what fields are associated with a doubly linked list? So they are talking about what fields or what properties. So what properties any node of doubly linked list has. So next, data previous next, data previous. So guys, just remember, just visualize the doubly linked list and then tell me if there is a node in a doubly linked list, what properties it will has. So you tell me the answer of this question in chat. So yes, so everyone is confirm. Is there anyone who is saying that the answer is not C? Anyone? Yes, everyone is so sure about that the answer is going to be C because a doubly linked list has previous and next and the data property. So let's move into the next slide. So yeah, answer is C. Let's look into this one. What is the time complexity of inserting the element at index n of doubly linked list when previous or next is not known? So देखो क्या कर रहे हैं? We have already done this question. In double linked list, they are providing one index to us, and at that index we want to insert an element. Like that index could be 0th index or 1 index or second index or 5 index. So what would be the time complexity for that? So see before that, how we will be reaching to that element? Because if in any index, if we want to insert any element or delete any element, we have to first reach to that index, right? First we have to reach to that index, then only we can do the operations. Everyone agrees with that? Everyone agrees with that? If you want to insert any in any node or any remove any node from any of the indexes, so first we have to reach to that place, then only we can do the insertion and removal. So for reaching to that place, we would be needing iterations. That much index they have provided us. If they have provided 3 index, so we have to do 3 iterations. If they are providing 4 index, we have to do the 4 iterations. So if they are providing n index, so we have to do the n time iteration. So that's why the time complexity here would be on. So let's see if that's the correct answer or not. Yes, so answer is D. Okay, so let's move into the next question. Memory allocation is dynamic in linked list. You guys tell me, is the memory allocation in linked list is dynamic? That's true, right? I already showed you that in the square box where we were talking about. So in linked list, we can assign many nodes, and those nodes would be at different places. So that's why that's the benefit of linked list. Memory allocation is always dynamic in linked list. So that's why answer would be true. So let's answer. Let's look for the complexity of insertion at last in a circular linked list. Okay, see, first visualize circular linked list, then visualize the last element, and then they are asking what would be the time complexity of insertion at last in circular linked list. You guys remember circular linked list? This is a circular linked list, right? This is 4. This would be the tail we have taken. And then this would be the start node. 5, 6. Then this will be. So they are saying if this is a circular linked list and if you want to insert something at this place, last place. So what would be the time complexity there? What would be the time complexity there? D or 1? Because do we need to do any of the iteration here? If we want to do if we want to do any of the if you want to add at the end of this tail in the circular link list, do we need to do any iteration here? You tell me, do we need to do any iterations there? In just take this example, right? Tail is here, right? This is circular linked list. That's what we designed, right? In last class. That's what we did, right? So to reach to reach last element in a circular linked list, do we need to do any of the iteration here? Everyone tell me. For reaching the last element, do we need to do any iterations in the circular linked list? No, right? Because we can directly access the last element with this dot tail. If we will print tail, so tail will provide us 4. comma next. So this is our last element. So we do not need to do any iterations to reach to last element. That's why in the circular linked list, the time complexity for inserting an element at the last position. That's why they have clearly mentioned last position, insertion at last. It would be O1. Understood everyone? Because we do not need to reach to the end of any end of the element. But in a single linked list, if we do not have tail, in the single linked list, if we do not have tail, at that time we have to iterate till end, then only we can reach the end element. But in the circular linked list, there is only one pointer, that is tail only, and tail is only telling us to go for the next element. So that's why in the circular linked list it would be 1. Understood everyone? Any confusion? Any confusion about the circular linked list or single linked list? Right? We are good, right? So let's move further. So searching an element can be achieved with which of the below linked list efficiently. Okay? अब देखो यहाँ क्या कर रहे हैं, ये सर्च कर रहे हैं एक एलिमेंट्स को. Okay? And they are saying which of the linked list would be give us better efficiently, which would be linked list which could give us better like result or faster result if we are talking about the linked list, right? So see guys, in the single linked list, if you want to do the search, you only can move in one direction. You can only move in one direction. But with double linked list, you can move into any of direction, even in the even into the right side or in the left side. Correct? अब देखो, just simple example लो कि अगर जैसे sorted कोई, if somebody has given you sorted links, sorted link list, right? So you can easily go to the third element, then you can easily go back from there. But in single linked list, you cannot do that. You have to again start from the starting point. So that's why always if you are doing if we are doing the searching and if you want to reduce our time, so it would be better to take the double linked list rather than single linked list. Understood? In the double, because in the double linked list we can go both direction, uh, to the right direction, to the left direction, in any from any of the node, we can go into any direction. So that's why the answer would be here that double linked list or doubly circular linked list. But the main point is double linked list or single linked list, which is better in while searching elements. So in those cases, double linked list is better. Understood, guys? Everyone agrees with that? Why double linked list is little bit better than single linked list? Okay, let's move into the next part. Okay, so they are saying this was the problem. So first tell me, anyone has tried these problems? And this you can see the first one on the single linked list, you have to implement two methods, get head and is empty. Anyone tried? Anyone has solved it? Likit has tried it, Vishal has tried it. Did you guys face any problem? Get head and is empty. Okay, so anyone wants me to explain this? How can we implement these methods? Get head is empty. They are saying in the single linked list, right? So let's see. This is our single linked list. 4, 5, 6. 6 is pointing out to null. This is the linked list which I am visualizing in my mind. And this is our head. And they are saying implement a get head method. So this will be very simple. In this get head method, simple return this dot head. Right, guys? That's what you need to do. And in is empty method, we have is empty method. So it means they are checking if length of linked list is empty or linked list is empty or not. So how can we check that? We already have the length parameter, right? So if length is equal to 0, 0, so we will return true. Yes, linked list is empty. Else, return false. Right, guys? That was the only two methods which we need to implement here. Correct? Vishal is saying if head is null. So yes, so that would be written from here, this dot head. So null, it means there is no null, there is no head. Correct? Understood, Vishal? Or you can simply put the condition also. You can simply put the condition also. If head is null, you can return some string like return, and you can say the head is none right now pointing out to null, something like that. Okay. So everyone understood this assignment problem, this first problem? Anyone wants me to explain it? Anything like that? No, right? We are good with that. We can move into the second one. Okay, let's see the second one. So anyone has implemented the second one also? They wants to implement the insert before, insert after, and search data. I think search data already. I think we have implemented this one, right? Search data already implement. Anyone has implemented insert before and insert after? Let me know in the chat. If everyone has already done it, let me know in the chat, or somebody who, okay, explain once again please. Which one? The second one or first one? Second one, right? Okay, so second one is saying implement insert before, insert after, and search data method for doubly linked list. Okay, Parag? So see what we need to do in the doubly linked list. Let me first clear it out these things. Yeah, so let's take very quickly one doubly linked list, which you have in your mind also. Just visualize it, same 4, pointing out to null. This is our head. This is 5, pointing back. This is 6, pointing back, and this is pointing to null. Correct? This is our doubly linked list. So they are saying insert before, right? Where was that? Yeah, so they are saying insert before. It means in insert before, this is one method they want to implement us, and they will provide us one position. Earlier, what we did, insert at. Do you guys remember insert at method? We have already implemented insert at method. So हम उसमें क्या पास करते थे? We pass the index and we pass the value which we want to insert. Correct, guys? These two things we pass. But here they are saying insert before. It means rather than passing index, they will pass this time the value of node. So they will pass this part, data, and second they will pass the value. So now rather than looking for index, we will be looking for values. And once we find the value, we need to do the same operations as we were doing in the index part. Once we find out the node, we have to do the same thing which we were doing for the insert at. Same goes for insert after. Same goes for insert after also. They will provide you data, comma value. So rather than looking for index, this time you will look for data. And once you've got the data, you have to insert at the after that node, like in this place, right? And this place, if somebody wants to insert after 5, they want to insert 8. So here it will be inserted like this. You can make the connection as we have earlier done. And if they want to insert before, they can do here 6, or like somebody else some other values like 1. They can provide you 1 here, and no data, they have to provide the data here. So like if somebody wants to insert before 5, they will provide you 1, and they want to insert 1, so in this place it will be inserted, and you can make the connection already shown you in the last class how to make the connections. Correct, guys? So that's what they are looking here. And in the search data method, they are saying rather than passing the index this time, you have to search for data. Same way, they will pass here like search for six exist in the linked list or not. So you will start looking for data part every time when you will do the while loop. In the while loop, like current next is not equal to null. Here you will be in all three scenarios. In all three scenarios, if node current dot value is equal to data, you have to do the operations. So this time this would be the important condition कि node का जो value property है, whatever node we are talking about, the value property of that should be equal to data, and there we have to do the operations. Understood, guys? That's what we need to do there. Understood, Parag? Yes, search data will return Boolean value, true and false. Everyone understood? Parag? Okay, so everyone understood, right? They can do it in the double linked list. Okay. So let's move further. Let's see if there is any other questions. Okay, so that's all from the last assignment part. Okay, guys. So let's move into today's topic, and today's topic is going to be very interesting. Okay. So today's first problem which we are going to get is a reverse a linked list. Reverse a linked list. Okay. So I am not sure. I've already posted the same problem in the LinkedIn group. Have you guys checked that? I think Ekta has already answered. She is already implemented it. What about others? Anybody has tried to implement the reverse of linked list? Ah, Vishal has already done. Very nice. Likit has also done. Very nice, very nice. Can anyone share the link of group to Deepak? Tried but could not do. No problem, Arad. We'll today look into that. Okay. What about others? Nobody has tried? Parag, Anand, Suraj, Sarad, Navneet. Anyone else? Deepak has tried. Okay. Not tried, couldn't do. Okay. No problem, guys. Let's jump into that one. In meanwhile, I have not seen. Okay, so Niranjan, you have to see into the group. So I mean, meanwhile, somebody share the group name so Deepak can join it, and then let's look into that. Okay, guys. So today, what I'm going to do today we are going to look for these problems in lead code directly, and today we are going to solve these problems directly in lead code. Okay, whatever problem we are going to look into that today, we are going to solve them in the lead code. Okay, so let's search for this one, reverse a linked list. Let's search reverse a linked list lead code. You guys can see my screen, right? Is it okay, right? Like if you will see why I'm going to look into the why I'm going to write the solution in lead code, because we might miss some of the edge cases while we are writing into our notepad or in our visual studio. In our editor, if you're writing, we might miss some of the edge cases, but when we will run into the lead code, so all the test cases, all the edge cases have to pass, right? So that's why we will get to know if we are missing any of the edge case scenarios. Okay, so you guys are able to see my screen, right? Let me know in the chat. Oh, great. So see, this is the question, guys. So what, and so you can see this comes into the easy category according to lead code. Okay, so let's see, given the head of single linked list, so they will give us head. You can see in the function they are providing us head. And what we have to do, we have to reverse the list and return the reverse list. You can see they are providing 1 2 3 4 5, and we have to return 5 4 3 2 1. If they are providing 1 2, we have to return 2 1. If they are providing empty head, we have to return the empty head from there. Okay, that's what. And they have given some constraint also, like this would be the range of nodes, and the values would be between -5,000 to 5,000. Okay, that is our problem. Everyone understood the problem? I think it was very easy. It was self-explanatory. No need to explain anything in the problem, right? So let's jump into that. Okay, so let's start from here. Let's try to think about it. How can we do it? Okay, let's see. When first time I was also trying to think. So whatever scenarios, whatever the thinking is coming into my mind, I will first try to explain them. Okay, so let's try to write it. This is the first one, this is 2, this is 3, this is 4, this is 5, and it is pointing to null. And from here, our head will start. Till now, we have understood, right? This is our linked list. Correct, guys? We are okay with that. This is our nodes. We have 5 nodes, and this is our linked list. Okay, so now what is our output? At the end, what we want? Let me write it into the blue part, blue color. So at the end, we want something like this: 5, 4, 3, 2, 1, and then null. Correct? That's what we want as a output. Agree? Right? That's what we want as a output. Okay? Okay, so now let's see. What would be our first thought? If we want to reverse something, what would be our first thought? So the first thought would be, like if this is a case of array, so what would be our first thought? So first thought would be somehow if we reach to the end element, and then from there we can start traversing back like this, and then while we are traversing we can just simply console them: 5, 4, 3, 2, 1. That would be the first thought will come, right? That would be the first thought will come, right? That's what the first thought comes into my mind actually. That was the first thought which come into my mind actually, कि somehow अगर हम देखो सबसे पहले यही आया अप्रोच कि अगर हमारे पास कुछ ऐसा होता, if I had something like that, if I can reach to the end and then I can go back from there. But this is single linked list, right? But this is single linked list. In single linked list, backing is not possible. In single linked list, backing is not possible. We cannot traverse back. You know that, right? In the double linked list, we can do that. If it is double linked list, we can easily do that. But in the single linked list, it's very difficult, right? We cannot do the backtracking, right? See, what is the other approach? Like other approach which comes into my mind. Like after thinking about this, what comes into my mind? Next thing I will tell you. Next thing in my mind comes like, okay, see, because I want 5 at the first, somehow I have to first reach to the 5. बिकॉज मुझे 5 सबसे पहले चाहिए, तो सबसे पहले कहीं ना कहीं से मुझे 5 में तो सबसे पहले पहुंचना चाहिए. ओके, आई थॉट ओके दैट्स फाइन, एंड आई कुड रीच हेड, आई कैन मूव माय हेड टू हियर, राइट? आफ्टर रीचिंग 5, somehow I want 4, correct? Somehow I want 4, then I want 3, then I want 2. So अब अगर हम हेड, अगर हमारा पॉइंटर हेड 5 पर है, and if we want something at the same time, if we want something at the 4, we can use one more pointer, right? And keep the previous here. That's what we have already seen it, right? In our problem, we have already seen this thing, right? We can take 2 pointers, and those 2 pointers which will always give us the current node and the previous node, right, guys? We have already seen that. I'm just telling right now whatever thoughts was coming in my mind. Okay, it might be possible the same thoughts were coming into your mind also while you were trying to solve this problem. Okay, so this is the second thought which come into my mind, that if we have 2 pointers, so 2 pointers will always give us 2 node. What after that? What after that? Like, okay, if I'm in the last node, I got the 5. Okay, I printed out 5. I got the 4. I printed out 4. What after that? How can I read? How can I now get that 3? How can I get that 2? How can I get the 1? That was now I cannot do. I cannot take multiple pointers, because at the same time, at one node we can only access 2 nodes, right? In single list, one with the current, one with the head pointer, and second with the previous pointer, right, guys? That was the second problem. Now this is also again, it's not going to work. This solution is also not going to work, क्योंकि अब हम मल्टीपल पॉइंटर तो ले नहीं सकते कि अब हम भाई मल्टीपल पॉइंटर लेते चलें, एक एक करके मूव चलें. This approach is also not going to. So now we need to think something else. Okay, so these two approach comes into my mind as a basic, like just simple thoughts comes into my mind. I think might be possible some people doesn't get this thought, but yes, these are the very general thought, everyone will get it. Okay. Now let's see. Now let's see again. Okay. Now the third thought could come. हमें देखो 5 तो चाहिए ही है. At the first we need 5 also. But same thing. If I am at the 5, if somehow I can get 4, like if I am at the 5, somehow if I can get reference whole list. When I'm at the 5, when I'm at the last node, I should be having all the, if there could be a way, if there could be a way, if I could get the reference of whole linked list when I'm at the 5, then there is a way, like if this whole linked list, the like whatever the elements before the 5, if they are, in any of the pointer, like temp, all elements, not one element, if all of the elements before 5 are referring, if they are in one temp variable, so what I can do at the end, I can simply do 5's next is equal to temp. Correct? If all the elements before 5, if they are somehow, I'm just guessing right now, if they somehow, they all move, they all can be easily accessed with one variable, so I could simply do this, right? 5 next is equal to temp. जैसे मैं ये करूंगा, I will get this list 5 4 3 2 1. Right, guys? That's the second, that's the third thought come into my mind कि अगर हम लास्ट एलिमेंट में पहुंचे और उससे पहले सारे के सारे जो एलिमेंट्स हैं उस लिंक लिस्ट के, इफ आई कैन जस्ट रेफर ऑल ऑफ देम इन वन पॉइंटर, देन आई ओनली हैव टू डू 5's नेक्स्ट इज इक्वल टू 10. करेक्ट गाइस? This could be just one thought, right? That could be one thought. Okay. Let's continue in that thought. Let's move before 5. Let's move before 5. This was the 5's discussion. Okay. And if we got the same approach for 4 also, if we think about the similar thing about the 4, so when I am at the 4th position, if somehow I can read all the elements here, right? If I am at the 4, if I can read all the elements before that in the same way, same temp, then that's also good. 4 3 2 1, right? Same goes for 3. Same goes for 3 also. If I am at the 3, if I can read all the previous element, then it's well and good. I can simply reverse it, right? See, I started my thinking from 5, then I'm moving one element back, right? Let's think about the 2 also. If I'm at the 2, if I can somehow make the reference with 1 or whatever element previous to that, that would be well and good, right? That would be well and good. So see, what we will do, guys, now we will come back to first element 1, right? And we have to make the same approach. So see what this approach is saying to us. What this approach is saying to us, whenever we are at, like जिस भी element पे हम हैं, in whatever element we are, we should be having some connection with all the previous elements. We should be having connection with all the previous element. So let's see, while we are starting our loop, at that time, if I'm just taking simple pointer like reverse, this is my simple pointer reverse, which is in starting pointing to null or having value as a null, right? This is before starting my loop of iterating any element. So right now, let's keep it like that, and let's write our linked list again. So 1 2 3 4 5 null. तो मैंने क्या बोला? What I said, guys, कि whenever I am at any element in this linked list, any of the node, I should be having the previous references. I should be having the reference of all previous elements. So let's see. Let's start from first node. If I am at the 1, what are the previous elements before that? No, right? If I am at the 1, there is no previous element. So what we will do? So when I am at this, let's take head into current or anything like head. I'm taking head into current, right? So right now current is this one, correct? Current is pointing to this element, right? And I am taking one more variable reverse, which is right now pointing to null. Okay, so when I am in the current element, so what I need to do, I need to point, I need to make, I should be having the reference of all previous element, or there is no reference of previous element. So I would be simply pointing to null only, because there is no previous element, right? There is no previous element, so it means I would be simply pointing to null for the one. So what would we do? I will follow the same line, this line. So once next is equal to reverse. Once next is equal to reverse. Let me write this code. Oh, what is one here? This is current. This current is one, but I'm just explaining you in the little way. So that's why one is next. Once next is equal to reverse. Okay. Now this once next is pointing to reverse. So now we can say, so now there would be new list like this, one null, right guys? One would be, once next would be null, correct guys? And now what I will do, I will update my reverse now I will make this one to my reverse, this one to my reverse. So what I will do, reverse is equal to this one, correct guys? Reverse is equal to 1, and then my current is equal to current dot next, current is equal to current dot next. Then I will just move further. Now you can see, when I'm at the one element, I have already reference of all previous element, and that is 1 to null, because there is no previous element. That's why I am referring to null. Let's move further. Let's go into the second 2. Now right now reverse is pointing out to 1, and 1 is pointing out to null. Okay, now let's move further. Now I'm at the 2. So what I need to do, again, 2's next is equal to reverse. 2's next is equal to reverse. जो भी इसके previous element है सबको 2 से जोड़ दो. 2's next is equal to reverse. अब देखो reverse में क्या क्या है, 1 to null. So now this list will be changed, and this list will become like this, 2 to 1, 1 to null. And then again we will update our reverse to 2, reverse to 2, correct? And then current is equal to current dot next. So what I'm doing here, as I am just moving further into the next element, whatever the previous element I have created, I am just adding it into the next, adding it into the next. You can see once next is equal to reverse. Earlier there was nothing, so I'm just pointing it out to the null. So that's why the first thing 1 to null. Next time what I did, when I move into the second, so second next, whatever all the previous elements, and the previous element I'm from where I'm getting, from the reverse pointer, and 2 to 1. And similar way, when we will go for 3, I will write that for 3 here. So 3 is next is equal to reverse. This is updated reverse, which would be reverse. So this would be 3, 2, 1 and null. Correct guys? Now again we'll update our reverse. Earlier reverse was pointing 2. Now update reverse will point out to 3. So reverse is equal to 3. And then current is equal to current dot next. Similar way it will reach to 5, and we will do the same step. 5's next is equal to reverse, and reverse is equal to 5, current is equal to current dot next. Understood guys? Was it difficult? Was it difficult? It was just the approach, how we how first we thought 2 ways. Then we reached to the last element. Then we thought, if somehow when I'm reaching at the last element, somehow if I could have reference of all previous elements, then it would be good and well, right? I will simply do 5's next is equal to that reference. That's what I explained, right? If I'm at the fifth element, if I'm at the, just think from the last element, क्योंकि हमें last element सबसे पहले चाहिए, तो हमें सोचना भी यहीं से start करना पड़ेगा. So when we are at the last element, if somehow I could have reference for all these elements in one variable, so I will simply do 5 next is equal to 10. अब देखो यही सेम अप्रोच अब 4 के लिए सोचो, यही सेम अप्रोच 3 के लिए सोचो, यही सेम अप्रोच 2 के लिए सोचो, यही सेम अप्रोच 1 के लिए. So once you will be at the 1, then what are the previous element? Nothing, null. So now 1 will be pointing to null. So that's what I did. Once next is equal to reverse. Reverse was null. So once next is equal to reverse. Then once I once I pointed out the next element for 1, I have to update my reverse, right? Because earlier reverse was pointing to null, but now reverse have one more element which was 1. So that's why reverse is equal to 1. So that's why as I will do the reverse equal to 1, reverse will be pointing out to 1 this time, and 1 will be pointing out to null with this line, correct? And then I'm moving into the next one. Now I will do the similar thing for 2, all the previous element. How will I get the previous element? With the reverse pointer. So that's what I did. 2's next is equal to reverse. अब 2 के next में सारे के सारे reverse के element आ रहे हैं. 1 then null, 1 and null, both elements are coming. Then I made my reverse, this one. क्यों बनाया हमने रिवर्स को? Why we are updating reverse? For the next element. जब 3 आएगा, सारे के सारे एलिमेंट उससे पहले हैं वो रिवर्स में होने चाहिए. So that's why I'm updating my reverse every time. Then I'm going to next element into the 3. So once I reach the 3, I did the same. 3 is next is equal to reverse. जो भी हमने रिवर्स में एलिमेंट हमने रखे थे सारे के सारे ऐड हो जाएंगे आकर के. देखो you can see 3 2 1 null, all elements are added before 3, right? And at same way, again we will update the 3. Why we are updating? For the next element which would be 4. So that's why 4's next is equal to reverse. Understood, guys? Understood, Arad? Was it difficult? Arad, understood? So one minute. Hariharan saying the linked list is forming from right to left. The linked list is forming from right to left. From right to left. From right to left. I didn't understand this one. So how we are forming our linked list? We are starting from first element, okay? And at that element, we are checking for all the previous element. We are checking all the previous element. Oh, okay. Right to left. Oh, yes. Yes, correct. That's right. So when we are at the third element, so then what we are doing? We are adding all the previous element to the next. All the see. Yes, you are right. So when we are at the third element in this one, we are adding all the previous one into the opposite, right to left. Yes. 3, 2, 1. Correct. Right to left. Yes. Please repeat, sir, the process. Okay. So yeah, the process is same, right? So first, I think rather than process, we should be thinking about the approach. What approach we have taken here? Understood, Nilanjan? हमने approach कैसे discuss करी? First we discussed about starting 2 approaches, which was not making much sense. But the third approach, which was making a little bit sense, that was if I can reach to the last element and I could get all the previous element connection, all the previous element connection at one place. That was we did. When we are at the 5th, if I could somehow get all these previous element in one pointer, and I was referring that pointer as a temp. If I could have something like that, then I would simply do 5's next is equal to temp. जितने भी एलिमेंट्स हैं इससे पहले वो सारे के सारे नेक्स्ट हो जाएंगे और हमें आंसर मिल जाएगा, क्योंकि यही हमको चाहिए ना. 5 के नेक्स्ट में सारे प्रीवियस एलिमेंट्स. यू कैन सी द नेक्स्ट ऑफ 5 ऑल प्रीवियस एलिमेंट्स. दैट्स व्हाट वी नीड. Okay, let's look the same. Let's look the same approach for 4. If I'm at the 4th position, if I could get all the previous elements, that's what happening, right? If I'm the 4th, get all the previous elements. Same goes for 1. If I'm at the 1 position, if I could somehow get the previous elements, which we do not have any previous element, it means null. So that's how we started. So once next is equal to null. So that's what once next. I rather than keeping the null, what I did, I taken one pointer as a reverse. This reverse will always have all the elements. That this pointer will always has all the elements. So that's why once next is equal to reverse. Reverse was null at that time. So that's why you can see 1 is pointing to null at first iteration. 1 is pointing to null. Okay. Then I updated my reverse because now reverse is not null. Now reverse has one element. So that's what reverse is equal to 1. You can see reverse is equal to 1. Then I move into the next element. What is my requirement? All the previous element. Once I got all the previous element, I will add it into the next. 2's next. That's what I did. 2's next is equal to reverse. Right now at the reverse, we have this whole 1 to null. So now you can see 2, 1 to null. Then again I updated my reverse. Same approach. Whatever we did for 1, do for 2, 3, 4, 5, and at the end we will get this reverse linked list. Understood, Niranjan? Reverse will be used like head. Reverse will be used like head. Do you mean we would be reversing our head? That's what you're saying? Can you explain your question, Likhit? In meanwhile, let's jump into the coding part, okay? While Likhit is writing here. Okay, so guys, let's look for the first condition, which is if our head is null, which means if the head is square, so they are keeping it as a head as a null. So we are saying if not head, so simply return the head from here. Okay, let's check this scenario if this is good or not. Let's check it. Let's empty all the elements from here. Let's run our code. Is it giving us error or anything like that? Yeah, it's looking good. Correct. So let's look for others. Let's now implement our code. Okay. Okay. So let's see. What we did, we have taken the current first. So let's take let current is equal to head. Correct, guys? Let current is equal to head. Right? And we have to reach to this element, and also we have to do the operation into this element. Correct? See, there are two scenarios, right? In the while loop, if you guys remember, we put two type of condition. Sometimes we put the same element, or sometimes we put current element dot next is not equal to null. Can anyone explain me what's the difference between these two conditions? If I am putting current dot next is equal to null, or while simply I am putting current, what would be the difference here? If I am putting simply current, or I am putting current dot next is not equal to null. Anyone can explain me the difference? Can anyone tell me the difference? You want me a little zoom it? Okay. Is it fine now? Deepak or everyone? Everyone can see it properly now? Yeah. Okay. So Likhit is saying, first thing Hariharan is saying. So previous and next can be tracked correctly. Okay, that is all about the previous and next. Okay. Last node, or it will go to the null node. Okay. Otherwise, previous will go to next and null. So see, let me tell you, let me explain you. Okay. So let's see. This is 1, 2, 3, 4, 5, and null. Okay. Now, if we are simply doing while current, let me explain you both differences. While current dot next is not equal to null. Let me show you both differences. What is the difference here? Console.log current dot value, and current is equal to current dot next. ऐसे ही लिखते हैं हम लोग. Current is good. Same, right? Same thing here also. Console.log current dot value and current is equal to current dot next. अब देखो यहाँ पे क्या होगा. सबसे पहले इसको रन कराते हैं, इस वाले को. Okay. So see, our current will start from here. Correct. Let's erase this part. ठीक है. Current will start from here. Now let's check. Current dot next is not equal to null. Yes, current dot next is not equal to null. Okay. Current dot next is not equal to null. Correct. Current dot next is not equal to null. Okay. So current dot value, it will print 1. Correct. Current dot value will be 1. Agree, guys? Now let's see. Now let's move our cursor. And now current is equal to current dot next. Now current would be here. Right, guys? Current is equal to current dot next. Okay. Now let's see. Again, current dot next is not equal to null. Yes, current dot next is not equal to null. Let's print 2. Let's move our cursor here. Same for let's come till 4. Right? Yeah. So when we are at the 4, we have printed out the value, correct? And then we did current is equal to current dot next. So now we are at the 5th element here, right, guys? Now we are at the current is equal to current. Now current is equal to current dot next. Now we are at this element, right? Now we'll check if current dot next is not equal to null. But here current dot next is equal to null, right? So now we will not go inside it. Now we will not go inside it. We will stop it here only. And now you can see our last element has not been printed out. Our last element has not been printed out. But in this case, same loop will happen. 1, 2, 3, 4. But when I will be at this position, at that time I am just checking current is equal to null, not current dot next is equal to null. So in this case, 5 will also be executed, and then this current pointer will move to null. And this current pointer will move to null. Okay, here current will be. So see why I was telling you the difference. So जब भी हमें कुछ operation करना है इस element के साथ, we want to do any operation with this element, then we will go with this approach. We'll go with this approach when we want to do any operation with this element. But if we simply want to stop our pointer at the last element, if we simply want to stop our pointer at this element, we will simply do current dot next is not equal to null. If we simply wants to stop, because see, let me just draw the same thing, because see, with this approach the last current pointer will be at this place, but with this approach our pointer will be at here. With this approach our pointer will be at this place. So see, that's what you need to remember into your mind. When you only want your pointer at the last element, then you will do this line, current dot next is not equal to null, and you will not be able to execute the last element. But in this case, when you want to execute the last element, then you will put while current. Okay, in the reverse linked list scenario, we want to execute this scenario, we want to execute this element. That's why I was going with while current. Understood, guys? That's why I was going with while current, not while current dot next is equal to null, because we want to do some operations inside that. Everyone understood the difference between current dot next is equal to null or current? I have showed you the difference, right? Let's look into the code now quickly. Okay. I hope you guys are able to see it. So let's see. Let's take one reverse variable here, which would be keeping our list. Let reverse is equal to null, right? The first element. This one, right? This one. Reverse equal to null. Now, what we need to do is first thing here, we need to take our current element in one variable. So let's take our current element in one variable. So we can refer the current dot next later. Correct? And then we can simply do cur is equal to n. Now, in this current element, we can do simple operations like current dot next is equal to, what we need to do, reverse, right? That's what I told you, right? One is our current element, current dot next is equal to reverse, and then reverse is equal to current. So that's what I will do. Reverse is equal to current, correct? And then current is equal to current dot next, which we have already taken in another variable. Current is equal to current dot next. Correct, guys? That's what we need to do only. And then at the end, we'll simply return our reverse. Reverse list increase. Let's run it and let's check if it is passing or not. Yeah. So 5, 4, 3, 2, 1. Yeah. So output is 5, 4, 3, 2, 1. And yeah, let's submit this one. That's what we need to do, guys. The same step which we did here, and you can see it got success. Understood, guys? That's what we need to do. That's why this was not very difficult question. That's why it was coming in easy. You can see this was coming in easy. That's the easy thing. Okay. So see, first we have taken the reference of our next element. Correct? So we are right now we are at this element, first element. So first we have taken all the element reference, so we can traverse it through the while loop. So that's why we have done let n is equal to current dot next, right? And then you can see I have used this n at the end. Current is equal to current dot next. And in meanwhile, in the current, I did these operations. Current dot next is equal to reverse. Reverse is equal to current. Same step, which we did here. Just we added one more line at the top. Let n is equal to current dot next. और इस n को हमने यहाँ use कर लिया. Correct? That's what we did. Let n is equal to current dot next. So we created a local variable for keeping all the next element like these, all these elements. And then we updated our current elements next address. Then we updated our current next element reverse. Is equal to current is equal to null. Current is equal to current dot next. So again, current will be updated to current will be assigned the same values which we have kept into n. Correct, guys? So that's what will happen. Everyone understood? Anyone want me to explain it again? Sir, one doubt. Current is equal to head. How to pick only one element? Means first element. Current is equal to head. Okay. How it picks only one element? Means first element. How it picks one element? No, it does not pick one element. It has picked one by one all the elements, right? See? Where is that? You can see current dot next. It is picking all the element, right? First time it will pick 1. Second time it will pick 2. Third time it will pick 3, 4, then 5. Right? In question, head is equal to yes. So first time head will pointing out to 1. Current will pointing out to 1. Correct? Then we taken one variable n. Then n is pointing out all the next element 2, 3, 4, 5. Okay. You guys are a little bit confused with that, huh? Already discussed this thing, right? So let's see 1, 2, 3, 4, 5. Right? Earlier current and head both are pointing to here. Right? This list. Then what we did, we created one variable n, and we are keeping all the elements of this here. So now n is pointing out to 2, 3, 4, 5. Correct? Now we have this only current element. Now in this current element, current dot next is equal to reverse. Right? So now this 1 is pointing out to null. Correct? This 1 is pointing out to null. Now reverse is equal to current. That's what we did, right? We made our reverse to current. So now this reverse is pointing out to null rather than pointing out to 1. Null. Then what we did again, current is equal to n. So now this current is rather than pointing out to 1, now it is pointing out to 2. Correct? Now again we'll get the 2. Same logic. We'll keep this all the elements of next in n again. So now n will be keeping 3, 4, 5. Now again we got the current 2 in the current. Then we will do the same operations. Then we'll get the 3, then we'll get the 4, then we'll get the 5. Understood, Hariharan? In question has equal to, sir, without current we can also do this. Then instead of current use head. No, with head, yes, we can do that here. With head also we can do. That's true. Because we are not going to use head further, so we can do with head also. Yes. I thought head is equal to 1 to 5, this whole thing. No. Head is one pointer. Head is just one pointer here. Okay. It's taking ON space, right, sir? Space. Let's look into the space part. So space wise, we are not creating any new thing. So space wise, it should not take ON, right? So this is another problem, okay? No, space wise, is it taking anything else? No. Space wise, it's taking just it's not taking any space there. Yeah, references are just one pointer. Reference is just one pointer. So reference is just one pointer. We're just moving pointer here and there. Moving pointer here and there. In memories, we are just pointing here and there. So we can, for the pointers, we can take small memories. That so in space complexities, when we are taking any new array, when we are taking any new objects, and those scenarios, we take the ON space. Time complexity could be ON here. Yes, time complexity is ON. Where it rating whole linked list. So definitely time complexity ON here. Okay. Understood, everyone? I think it was very easy, right? So why in this problem we have not proceeded with current.next? We have current.next, right? You see, we are using the current.next because we want to because we want to change the current element. We want to change the current element. You can see, right? We are changing the current element, right? One.next. That's why we have already taken all the reference of all the, like, whatever current is pointing out, we have already taken into the next element into n, and then we are doing all the operations in current element. Then at the end, we are updating our current to older linked list or the remaining element. Okay, Riren? Sure. I think I already have this code here. I will push it. Okay. Let's jump into the next question. Understood, everyone? Can we move into the next question? Okay, great. Let's move into the next question. So next question is, guys, folding and slash reorder a linked list. Okay, so this question is little bit difficult. So before understanding this question, I want to explain two things to you guys, which are also a different problems, right? And those problems we are going to be like internally used in this problem. So the first problem is find a middle element. Let me put that question. Middle of linked list, yes. So this is one more easy problem. First we'll do before jumping into this one. Okay. Before jumping into this problem, we'll do first this problem. And then we will jump into that one. Okay. I know the solution. Okay. That's great, Deepak. Okay. So see, guys, let's take one example very quickly. Okay. Okay. So let's see, guys. Everyone can see my screen? Everyone can see my screen? Okay. Great. So let's talk about little math. Let's talk little math here. Okay. And should we talk about here only? Because okay, let's talk little bit about math. Okay. So let's see if we have a 10-meter like race, like where we do the sprints. So we have 10-meter race here, where we can say we mark it like 1, 2, like these are just 1 meter, 4, 5, 6, 7, 8, 9, and 10. Okay, guys, this is 10-meter race track. Understood? Okay. Now we have two people, A, and we have another person, B. Okay. And now there is one more condition. We will run 2 times faster than A. So like B will be speed of B would be 2 times speed of A. Okay. So you guys have to tell me, okay, let's see how they will run. So I will draw the A with the marker of with a blue marker and the green this one with black. So let's see. And they are in 1 second, in 1 second, A is running 1 meter, and B, because it's double of speed, it will be running 2 meters. Right, guys? A would be running 1 meter, B would be running 2 meters. Right, guys? That would be the case. Okay, so let's see. So if both are starting from the same place, if both are starting from the same place, so A would be here and B would be here. Correct, guys? Let's look again. Next time, this is A, right? Blue with the blue. Next time, A is here, B would be here. Correct, guys? Again, A would be here, B would be this place. Correct? Same goes here. A would be here, B would be at this place. Correct? And A would be this place. And this would be crossing it. Right? This would be crossing it. And A would be at this place. This is A destination. This is A journey. And this is B journey. So with this knowledge, with this calculation, what we can understand? What we can understand that if somebody is running at 2 times speed, somebody is running at 2 times speed, so the other person who is running like while they are running at the like at the same time, if we have one track of 10 meters, so at the same time, if somebody is running faster, like 2 times faster than the other, then that person, when that person will hit the end, at that time, other person would be at the mid of place, would be in the middle of somewhere, right? Would be in the middle of somewhere. Correct, guys? That's what we can analyze with this scenario. Right now, you can see these are 10 elements. Now let's take about the 7. 1, 2, 3, 4, 5, 6, 7. If we have 7 meter long track in the odd scenarios, I'm saying this is odd scenarios. So 1 say 3, 3 say 5, 5 say 7. If we talk about the slower one, so slower would be here, slower would be here, and this would be here. Always slower one would be at the middle. In the odd, you can see simple, the middle. In the even scenarios, if the track length is even, so it would be at the second middle element. You can see in the even scenario, these two elements are coming into the middle. So this will be coming at the second middle, second last. Right, guys? Can you guys understand? Did you guys understood this theory? If we are running at the even track, even length track, and if B is running at the second 2 times speed of A, so when B will be touching the last distance so the A would be in the middle of somewhere, in the middle of that length, middle of that track. Same goes for the odd also. Did you guys understood this thing? So distance of A divided by speed of B is equal to distance of B divided by speed of A. Yes. So because both are taking same time, so distance of A divided by distance of A, distance of A would be speed of A, and same goes for this, and then we can say like this: distance of A multiplied by speed of B, and distance of B multiplied by speed of A. Something like that equation can come. Okay, but yeah, did you guys understood this part? That the faster one, when that faster one would be at the end, at that time element would be at the middle of that. The slower one would be at the middle of it. Okay, everyone understood this thing? Yes, distance of first person is half of distance covered. Yes, that's totally right. Hariharan has put it correctly. Whatever distance faster will cover, at the same time, the slower one will be having the slower one would be covered the half of distance. That's totally right. Slower one would be covering the half of distance, right? So see, now let's relate this knowledge with our linked list. Let's relate this knowledge with linked list. So if we are having the odd length, if we are having the odd length of linked list like this, 1, 2, 3, 4, 5, 6, 7, and null. You can see how many elements are there. 7 elements are there, right? So if we have 2 pointers here, fast and slow. So if fast is moving 2 times, so how will move fast 2 times? Fast is equal to fast dot next dot next. Correct? So if fast is moving 2 times, if both are starting from same place, if both are starting from same place, so fast would be here, first time, after first iteration. Slow will be at this place. Then fast would be at this place. Then slow would be at this place. Then fast would be at this place. And slow would be at this place. Then this will be our answer. Then if we want to find the middle element, then slow would be our answer. Slow would be our answer. And what would be the condition for stopping fast? What would be the condition? The first condition would be while fast is not equal to null. तब तक loop चलेगा. जैसे ही fast के not this. Fast next. You can see we have to check fast next. Fast dot next is not equal to null. Correct? This is for odd scenario. Let's look for even scenario also. This is for odd scenario, right? Let's look for even scenarios also. So 1, 2, 3, 4, 5, 6, 7, 8. This is our even scenario, right? Even length. Let's do the same. Fast, slow. So fast would be first time here. Slow would be here. Fast would be here. Slow would be here. Fast would be here. Slow would be here. And then fast would be here. And then slow would be here. Correct? This would be the second last, because in the even scenario we have 2 middles, so we have to take the last middle. So now the condition would be while fast and fast dot next is not equal to null, we have to simply traverse it. We have to simply traverse it. These are the 2 conditions we need to put, and then we will get the slow. Once wherever our slow is, we will just simply return the output from there. And that's what the question is also, guys. That's what the question is also. So you can see, given the head of single linked list, return the middle node of linked list. And then if there are 2 middle nodes in the event scenarios, we have 2 middle nodes. So return the second middle node. And that's what happening here. You can see in the event scenarios, we have 2 middle nodes. So that's why we are just returning the second one. Slow will always return. We have to just simply put these 2 conditions, and then we will simply reach wherever our slow is stopping, we will be simply returning that one. Everyone understood this thing about the fast and slow? Yeah, this will not be end. Sorry guys. Yeah, this will not be end. Sorry for that. This would be or only. Any one of that. Fast or fast dot next. Any one of that. Yeah, that's right, Likit. Understood, Hariharan? I explained the condition again. This the first condition is for even scenario. You can see fast is stopping at the last element, and fast dot next is equal to null for odd scenario. You can see fast would be stopping here. Understood? The loop only stops at null node. Yes. So nodes next is equal to null or node is equal to null. Anywhere. If any one of the scenarios we get, we will stop it there. Because in the even scenario, it will be stopping at node is equal to null. On the odd scenario, it will be stopping at node dot next is equal to null. Okay. So let's quickly implement it. Let's quickly. Arad is confused about which while condition part, or about the fast and slow pointer. Why 2 middle nodes? Arad is confused about why 2 middle nodes. Okay. So see, Arad, if we had 4, 5, 6, 7, 8, 9, you can see 6 elements are there. 2, 2, 5, 6. So what are the middle elements in the even scenario? What would be the middle here? You tell me. What would be the middle? How will you calculate the middle position here? In the odd scenario, it's easy, right? In the odd scenario, it's easy. This is middle. All the left side of that and right side of that equal. But here, these are the two elements in the middle. In the even scenarios. In even scenarios, always two elements are middle. Because what is the meaning of middle? It means which divide all two sides equally. Which divides all two sides equally. In the odd scenario, there is only one middle, which divide two sides equally. But in the even scenario, you can see there are two elements which divides a whole array into two elements. Understood, Arab, now? Why there are two middle nodes? Yeah. And we need to take the second middle node. We need to take the second middle node according to the problem. You can see, return the second middle node. Okay, let's quickly now implement it. Let's first take our slow pointer. That would be pointing out, okay, first, that edge case, if not head, return head. Okay, then let's take our slow pointer first. Head. Let's take the faster one also. In this scenario, we can run from both, like both can start from same point. Okay, and what would be our while condition? Yeah, fast is not equal to null, or fast next. This would be for fast dot next would be for odd scenario. Is not equal to null. Correct? Then what we need to do? We need to simply slow is equal to slow dot next, because it has to run only one time, and fast has to run two times. Fast is equal to fast dot next. Correct, guys? That's what we need to do. And then wherever they are stopping, we will simply return the slow. Simply return the slow from there. Let's see. Is it running? It is giving correct answer or not? Or we are missing anything? Okay, so cannot read property of null. So fast dot next is equal to null, and fast is not equal to null. It should stop here, right? Am I mixing anything? Fast is equal to fast dot next, and slow is equal to null. Fast is not equal to null, or fast dot next is not equal to null. It is going inside a loop. That is weird. Did you guys see any problem here? It is going inside a loop. At the end, so we are moving two times here, right? Let's see our code again. Let's take again example, right? No problem. So 1, 2, 3, 4, 5. That's our input, right? 1, 2, 3, 4, 5. Okay, so we are starting from here, slow and fast, correct? And then we check while fast is not equal to null, or fast dot next is not equal to null. Let me see first in the chat if you guys have already seen any problem there. Fast dot next is not equal to null. No. That's not right. Fast dot next is not equal to null. That would be because you can see in the odd scenario, we are only going to check fast dot next is equal to fast dot next is not equal to null, right? If the fast is second last node, the while loop will be true. But yeah, that would be this scenario, right? Even scenario, second last node. Then it could come into this one. Fast is equal to null, correct? Okay. So let's see. Let's look for the odd scenario. So fast is not equal to null. Where is that? Okay. Let's look into our code. Might be we are missing something. Yeah. Let's look into code. So fast is yeah. Yeah. So yeah. So fast. So okay. Correct. So this will pass condition. Slow is equal to slow dot next. So now slow has moved to this place. Slow is equal to slow dot next. Okay. And fast is equal to fast dot next dot next. So fast is equal to fast dot next dot next. So fast would be here. Correct. Now next see. Fast is not equal to null. That's true. Fast is not equal to null. Then slow is equal to slow dot next. So now this slow will be moved to this place. Okay. And then fast is equal to fast dot next dot next. Okay. So fast is equal to fast dot next dot next. So fast will be here. Correct. Now fast is not equal to null. Ah, okay. I think this would be end only. I think this will be end only, guys, because when fast is in both conditions should be true, then only we should be inside our loop. Yes, both conditions should be true. Then only we should not going. Then only we should go into this loop. I think yeah. Now this will pass. That was the problem. I think end only. Yeah. Did you understood? I think Likhit was telling me about the removing the or part, but yeah, we cannot remove that or part from there because in both scenarios we have to stop, right? Once the fast dot next is equal to null, any of the condition is becoming true, we have to stop there. Any of the condition is becoming true, we have to stop there. That's why we have to use the end. Understood, guys? Why for odd scenario fast? This is the scenario, right, Hariharan? You see, the fast dot null, fast dot next is equal to null. That's why we have to stop there. Understood? Understood? Uh, this approach is out of box. Out of box means so good. Okay, but you said for odd and even. I'm confusing it. Yeah, yeah, yeah. This is odd scenario, right? For odd scenario, we will be stopping at fast dot next is not equal to null. I have showed you, right? With this example, I showed you. For fast, we have to check for fast dot next. Wherever the next element is null, we have to stop. And that will only happen in odd scenario. Because in the even scenario, we will always get any element. We will always get any element at the last. Because you can see fast is only running at odd places. Fast is only running at odd places. So जहां पे भी fast का next null हुआ, it means we have to stop there. It means we have to stop there. So that's why I did fast next is equal to null. That's why I did fast dot next is equal to null. For even scenario, fast will be moved into the null part. For even scenarios, wherever the even length is, fast will move into the null part. So that's why I kept fast is equal to, only fast is equal to null. Wherever fast is equal to null, stop into there. In the even scenario, for the odd scenario, fast dot next is not equal to null. जहां पे भी fast का next null हो गया, it means it's odd scenario. Or wherever fast has become null, that means that's the even scenario. Understood, Hariharan? And see, wherever fast has become null, it means it's the even length. Or wherever fast dot next becomes null, it's the odd length. Now you got it, guys? Right, guys? So we can't think this approach. We'll just find length and traverse its half until half length. That will take a lot of time for finding out the length, and then and they are asking you to find out the give us the slow pointer, not the length. They're telling you to give us the yeah, that's also fine. Traverse till until the half length. Yes, that's also right. You can try, but that will be a little bit complex, right? This one is easy one. You just need to think about the runner simple runner scenario, and then according to that, you need to traverse your pointers. Yeah, for while loop, any of the condition is false, have to exit from loop. Yes, that's totally right. Anand. Can you show the code again? Yeah. Not sure I had this code or not in my. Let me check in the linked list or anywhere I have this code. Oh yeah, we will be having this code here. Okay, yeah. At rotate. Where is rotate? Reverse is, yeah, we will be having this code here. Correct. Yeah. Okay, guys. So that was the problem. But this is not our original problem. Our original problem was not this. Our original problem is this. I will show you. Our original problem is this one. Folding slash reorder linked list. That was just the part of that problem. Real problem is this thing. Reorder list. Now we will be talking about the real problem. This was just the part of that problem. Okay, this is the medium complexity problem, guys. This would be little bit complex. Let me first remove all the code which I already did earlier. We'll do it from the starting. Okay, so see what they're saying. You are given the head of single linked list. This list can be represented like this: L1, L0, L1, L1, L, like all the lengths, like similar like I showed you the race track, right? 0, 1, 2, 3, 4, 5, similar way. And then what you need to do, you need to reorder the list in the following form: L0, Ln, L1, Ln minus 1. So let me show you how you have to do it. Again, the even and odd scenario. If you have something like this, 1, 2, 3, 4, 5, this is your linked list. You need to output like this: 1 to 5, 2 to 4, and then 3 at the end. So something like this: 1, 5, 2, 4, 3, null. This is for odd scenario. For even, 1, 2, 3, 4. So for even, it would be 1 to 4, 2, 3. That's how you need to do the reordering. That's your output. Did you guys understood the problem? What do you need to do here? You can see the here also. 1, 2, 3, 4. They did 1, 2, 1, 4, 2, 3. Same here. 1, 2, 3, 4, 5. 1, 5, 2, 4, and at the end 3. That's what you need to do the reordering here. Understood, guys? Understood, everyone? Didn't understand? Okay. See, Arad, so we have one linked list like this 1, 2, 3, 4, 5. हमें इसको अरेंज करना है. किस तरीके अरेंज करना है कि फर्स्ट एलिमेंट लास्ट एलिमेंट साथ आए. देखो 1 to 5, then the second element and second last element will be coming here, then the middle element. You see here also first element, last element, then second last, and then the second element, second last element, and then at the end null. That's how you do to do the rearranging of linked list. Understood, Arak? The rearranging, resorting of that. That's what the problem is. The problem name is reordering list. So we need to change the order of that. Understood? Then 1 and 5 should change place. Yeah, 5 is at this place. Yes, that's right. 5 will come at this place. Second 2 will be coming here. 3 will be coming here. Yeah, you can see. Understood? First understood the problem, guys. What will change place? What will happen? We'll talk about it. First you understood the problem. First talk about that. Understood, Arad? You still didn't get it. Okay. Can you see this thing? Okay, let me, I think is it that much difficult? Okay, let's take another example then. So 4, 5, 6, 7, 8, 9. This is our linked list. Okay, first element, last element has to come together. 4, 9. Second element, second last element has to come next. 5, 8. Then 6, then 7. And then null. No, no, no. I think this would be 7, 6. Something like that. 4, 9, 5, 8, 6, 7. I think 6 will come first. I think. Yeah, 6 will come first. 6, 7. You can see how they are saying a. Let me see also. A0, AN. Yeah. So they are starting from A0. A0. So 0, 1, 2, 3, 4, 5. So A0, A5, A1, A4, A2, A3. That's how it should look. You can see A2, A3. Yes, this will come first. 6 will come first. Now you understood? You can see that's how they are running it. L2, Ln minus 2. What about the total length of that? Okay, this is not the odd scenario. Okay, 3, 3, 6. Okay, this was not the odd scenario. Okay, so odd scenario would be 5, 8, 6. So for this, 4, then 6, then 9, then 8, then 5. So A0, 0, 1, 2, 3, A4, A1, A1, A3, A2. Understood? Great. Everyone understood now? Everyone understood? Okay, great. No problem, no problem, no problem, no problem. Okay, okay. So let's see, guys. I'm just taking first the odd scenario. 1, 2, 3, 4, 5, 6, 7. Correct? हमें output क्या चाहिए? Again, we need to think about it. What's the output we need? 1, 7, 2, 6, 3, 5, 4. Correct? That's what the output we need. Right, guys? क्या मैं इस आउटपुट को ऐसे लिख सकता हूं 1, 7, 2, 6, 3, 5, 4 and null. Can you see a little bit like can first thing can we write this output like this? Totally we can write, right? 1, 2, 3, 4, 7, 6. With this, is there anything is coming into your mind? After writing our output like this, anything in coming into your mind? Any thoughts? After writing our output like this, any thoughts in coming into your mind? Yeah, whatever. Yes, definitely we have to break. So Nilanjan and Deepak is saying break. So yes, definitely we need to break it. But from how? And okay, that's fine. That could be one approach. The break is there, but they say about the dinner break. Oh, okay. You guys are telling about the dinner break. Oh, I was thinking like you guys are talking about the solution approach here. Okay, yeah. What is the time right now? 9:37. Okay, okay. Then yeah, we can go for break. I was thinking like you guys are talking about the approach here or something is coming into your mind. But yeah, break is coming into your mind. That's fine. Yes. So let's connect back. Yeah, I think it's an interesting question, guys. We'll do it. We'll talk about more. Yeah. So right now it's 9:37. So we can come back at 9:52, right? 9:52. We can come back. Okay, and meanwhile, let's think about it. What we can do there. You can see this output. Let's think about it. Like what we can do here. Okay, let's see. Let's think. Let's take a break and think about it. Okay, guys, we'll talk after 15 minutes. Everyone back? Okay. So yeah. So you guys think about any of the approach, anything which is coming into your mind after seeing this figure of our output. If we divided our output like this, 1, 2, 3, 4, and then 7, 6, 5, can you guys think about any of the approach? So Suraj is saying, print the head and tail, two-step head plus plus and tail minus minus. Acha. First thing, we do not have tail here. Okay, Suraj? We only have head of one linked list. Next thing, what you said, two-step head plus plus and tail minus minus. So when you are saying tail minus minus, what will it give us? There is no tail minus minus. Tail is not a number. Tail is pointing to one object. Correct? And we can't move back. That's totally right. Likit has mentioned correctly. So let's see, okay, what when I'm seeing this thing, what I am thinking. Okay, let's first wait. Is everyone back? Nilanjan, Deepak, Ankit, Arad, everyone is back? Okay, Vishal has given one idea that we can skip one node in between and skip node can be reversed. अच्छा ठीक है तो अब देखो तुमने बोला कि we can skip between nodes, right? So 1 or 3, between 1 or 3, 2 is there. So you want to skip that node. So 2 is there, 4 is there, then 6 is there. And then you are saying to reverse it. I'm not sure. Are we going to are we going to reach any closer? Yeah, right? That's a problem. But yeah, that's a good idea actually. That's a good idea. Vishal, that's a good idea. It means you are thinking. Let's think a little bit more. We have to do something like that. But let's think little bit more. So can you see what are the numbers which are only reversing here? If you see this pattern, what are the number which we are reversing here? Can anyone tell me what are the number in the output which are really reversing? So Likit is saying first hand and second half. So he's saying both are reversing. Hariharan is saying second half, second and second half. What about others? Can you guys see that the second half is reversing here? Can you see that? The second half is reversing here. Everyone? Yes. So that's what the approach here. So first guys, what we need to do, we need to find the mid element. First we need to find the mid element, right? This is odd one. So yeah, this is our mid element. And after that, whatever is coming, just reverse that one. After middle element, whatever is coming, just reverse that. And then after reversing, we will get two linked list. One is the reverse linked list, and then we have our original linked list. That's what the approach is here. Video gone? Oh, sit. Okay. I have not shared the screen. My screen was not shared. Oh, I explained that much logic and you guys not able to see that. I know, because I have not shared my screen. And I have explained everything. No problem. Okay, I think, but you guys have heard me or not? Whatever I explained. Oh no, okay, that's fine. Wasted my whole hard work. Okay, so guys, what I did, not sure you guys have seen this thing or not. Let's see. You guys can see it now, right? You guys can see and hear me now, right? Right. So see, what I showed you, I have written the output like this, right? 1, 7, 2, 6, 3, 5, and 4. And then it was null. Then we discussed if we can reverse our second half, right? That's what we discussed, right? That's what you heard right last time. Then we have to reverse the last second half. So what we will do, first we will find the middle element. First we will find the middle element, and from the middle element we will reverse our linked list. From the middle element we will reverse our linked list and save it into one pointer. Save it into one pointer, and that pointer will be known as reverse. Something is lagging, so now my system is also started lagging. Reverse. Okay, and then we will write like this: 1, 2, 3, 7, 6, 5, and 4. Okay, then we will write like this: 7, 6, 5, 4. And then we will make the connection. Then we will merge our linked list like this. You can see 1 say 7, 7 say 2, 2 say 6, 6 say 3, and 3 say 5, and then 5 say 4. And then we will get our output 1, 7, 2, 6, 3, 5, 4. Right, guys? Same goes for even scenario also. So 1, 2, 3, 4, 5, 6. We will reverse our linked list from the middle element. So you can see 6, 5, 4. We have reversed our linked list from here. And then you guys can see we have merged it. 1 to 6, 6 say 2, 2 say 5, 5 say 3, 3 say 4. Understood, guys? That's what we are going to do it. What is that? Can you guys hear me? I'm not sure. You are saying, can we try something like that? What do you guys want to try it? Okay, so I will also try meanwhile, because I already done the starting two parts, right? I already done that starting two parts. So let me meanwhile implement those two parts. So first let me find out the middle element. Already done that, right? And then let me reverse the second part. In meanwhile, you guys also want to try. So let me paste this problem to you guys. Whoever wants to try it. Otherwise, we will try it here. I will try it in front of you, everyone. Okay, because I already done this, so I will just copy paste it. Already done the middle element finding part, right? That is already here. So I will take the code from here for finding out the middle element, right, guys? So this was the middle element finding. Slow will always give it the middle element. Okay, so now we have the middle element, which would be slow. So now if you want to change the name also, so we can change the middle also here. Oh, that's fine. Slow is giving us middle, right? Or you can create a new one also. Let middle is equal to slow. Correct? So now middle is also pointing out to slow. Now we need to do the reverse. For reverse, what we did? We have taken one variable reverse. is equal to null, then while middle, let n is equal to middle dot next. That's what we did in the middle, right? N is equal to middle dot next. Then middle dot next is equal to previous or reverse, because we have taken reverse. And then our update our reverse to middle. That's what we did, right? Same code. And then middle is equal to n. Correct? Now we'll get the reverse linked list here. These two steps already done earlier also. No confusion, right? We have already reversed our linked list earlier also. You guys can see the code earlier, reverse linked list code. Right? The same code. We have taken one variable previous. Then in our current, this become middle now. The same code. Now in the previous, we will get the linked list here. Now here we'll get in the reverse. So now we get the reverse linked list. Correct, guys? Now we need to do the merging part. Understood, guys? Yes, both approaches will be discussed earlier, will be used. Can you guys hear and see me? Is checking for. Okay, so now you guys can also see my code, right? Which I did here. I have not run anything here till now. I just copied pasted whatever we did earlier. First we find out the middle element that is coming in slow, and I just pointed out through the middle. Then I reverse our linked list from the middle. Correct? So now we can say say we have two linked lists here. We can say first as a head. This is our first linked list where we have head, and then we can say second linked list which we have as a reverse. Right, guys? We have two linked lists. Everyone agrees? Now let's talk about how to merge these two linked lists. Let's draw them and then try to merge them. Okay? And I'm just praying my marker should work properly. Otherwise, it will create a problem. Okay. Till now, I'm happy. So let's take the odd one first. 1, 2, 3, 4, 7, 6, 5. So 1, 2, 3, 4. No, only 1, 2, 3. Sorry, 1, 2, 3. Because इसके बाद से तो हमने already null कर दिया है, right? 1, 2, 3. इसके बाद null, and then we have reversed it, right? 1, 2, 3, 7, 6, 5, 4. 7, 6, 5, 4. Then we have null here. Correct? My marker is working good. Okay. Now, guys, you can see this is our first linked list where we have pointed out first. Correct? And then we have our second linked list, second pointer, and head is also here. Right, guys? And then we will take one more pointer, temp here. Okay? We'll take one more pointer, temp, which would be pointing out to null first. Because temp we will use just for moving from here to there, because we need to move between two linked lists. So that's why we need to keep the store. Like once we are accessing this element 7, we should be having the reference for all the remaining elements. So that's what we'll store into temp. Like at whatever element we are right now, we have to somehow store the next element of that. So that's why we'll use the temp there. Understood, guys? So these are the like we can say total pointers which we had. Okay, temp, first, second, and head already there. Okay, so let's start from and see, guys, what we need to do. The second list we are reversing, right? So we should stop when we got the second list next is equal to null. Whenever we are getting second list null is equal to null, second list nodes next is equal to null, we'll stop there. Because सबसे पहले ये list आएगी ना. So our condition would be while second dot next is not equal to null, then only go inside the loop. If once you find out the second next is equal to null, you have to stop it there. Okay, so let's start from our first row. So first take this element फर्स्ट, इसके नेक्स्ट को टेम्प में सेव कर लो, इसके नेक्स्ट को टेम्प में सेव कर लो. सो temp, okay, I'm not able to write it properly. Temp is equal to first dot next, right? So first के next को हमने सेव करा लिया. Why we are saving? Because we need to change the first next. This first next we need to change. We need to add this second there. This second first node 7. That's what we need, right? 1 7. That's what we need. 1 7. We need to add these two nodes. So that's why first I saved all the reference of next element in temp. Then after that, what I did? What happened? Yeah. So first dot next is equal to second. First dot next is equal to second. Correct, guys? First dot next is equal to second. That's what we need to do. पहले हमने फर्स्ट के सारे रेफरेंस को जो भी उसके नेक्स्ट में था, ये 2,3, इसको हमने टेम्प में स्टोर कराया. एंड देन वी हैव चेंज द फर्स्ट एलिमेंट. फर्स्ट डॉट नेक्स्ट इज इक्वल टू सेकंड. करेक्ट? एग्री गाइस? नाउ दिस फर्स्ट का नेक्स्ट चेंज हो चुका है. one has been like the new linked list will look like this. 1 7. The new linked list will look like this. 1 7. If we stop our loop here only, so our linked list will look like this. 1 7 and what is next? 6 5 4. 5 and 4. Our linked list will look like this. If we stop after one loop, after doing these two operations, our final output will look like this: 1 7 6 5 4, because we have added our second linked list to first element. Correct? Now, once we added this element, now we need to move our first to this element. Now we need to move our first to this element. So now what we will do? First is equal to temp. अभी तक temp जो भी कर रहा था, अब वो first भी करने लगेगा. First is equal to temp. Correct, guys? Now our first is also moving to temp. Now first would be here. Correct? At the second element, जिसको अभी temp point कर रहा था. Agree, guys? That would be first. Now we have done the same for first. We'll do the same for second also. Because अब हमें 6 लाना है, right? 6 को add करना है after 7. After 1 7, we need to add like 6 also, right? So let's see. So first we'll do temp is equal to second dot next. Second dot next. Same thing for second also. Whatever is coming in second, my marker is just dying, it looks like. Now this 6 part would be saved in temp. Right, guys? Now this 6 part would be saved in temp. What we need to do now? This 2, this first we have to add in sec 7. So now that's what we do. Second dot next. Oh, my marker work properly, yaar. This is just so hard. Second dot next is equal to first. Correct? Now my first is at 2. Correct, guys? I hope you guys are able to visualize it. And then we will change our second to first. Sorry, second to temp. Now our second will move to temp. So it's very easy, guys. Let me visual. This is only code we need to write. These 6 lines. Let me see first. You guys are able to see me. You guys are able to see me and hear me. You guys are able to hear and see me. First, tell me. Yeah. Okay. So let me explain it again. What I did, guys. These are the 6 lines only we need to write. What we need to do, guys. This is our first linked list. 1 2 3. Right? This is our second linked list. 7 6 5. We need to add like this. 1 to 7. We need to make connection like this. Let me take any other color. 1 to 7. 7 से 2. 2 से 6. 6 से 3. अभी कैसे करेंगे? So first start from first element, which is 1. Okay, इस element में मुझे 7 add करना है. We need to add 7 here. So somehow take all the element which is pointed through the 1 in some variable, in some other pointer. So that's what we did. In temp, store all the elements of all the next element of first, all the next element of first. That's what the first line is doing. Temp is equal to first dot next. Then after storing the pointer, add the 7 to the first, to the next of first, because that's what we want in output. So that's what the second line is doing. First dot next is equal to second. Second was pointing to 7 right now, so that's why first dot next is equal to 7. अब जैसे ही मैंने 1 to 7 को ऐड कर दिया, let's increase our first to 2, because अब next time ये element ऐड होना है पहले वाली लिस्ट से. From the first list now 2 has to add it, so that's why first we will move to temp here, because this was all the data we are storing in temp. So that's why the third line first is equal to temp. Now our temp is free. Now we can use our temp in any other places. Now second in the second linked list we went, because now in the second linked list after 7 we need to add the 2. Same thing. First take all the next element of 7. So that's what we did. This line temp is equal to second dot next. All the elements which are behind the 7 we need to take it, because why? Because after 7 we are going to add 2. So that's what we did. Second dot next is equal to first, because first already moved our first to 2. So second dot next is equal to first. And then whatever was in the temp, because अब हमें second को भी अपने move करना है, so now second will come in this place. So that's why second is equal to temp. Now again loop will continue, because second dot next is not equal to null. So again we'll go into the 2. So now you can see our list after first iteration, our list will look like this: 1 7 2. Right? Our list, our final head will look like this: 1 7 2. Now we start again all the next element of first, which would be 3 only. All the next element of first, which will be 3, will be stored into temp. This is the first line doing that. After that, wherever right now second is, add it after the first next. That's what first dot next is equal to second. So now 6 will be added. 1 7 2 6. Right? Then again move the first to temp. So now first will be moved, because ये सारे element already traverse. So now we'll move into this one first. Then now go for the second linked list. There also we need to move. So that's what we did. All the wherever right now second is, second will be an 6 element, right? Now take all the rest element. So second temp is equal to second dot next. We have taken all the remaining element. Then because 6 हमें 6 के बाद 3 को ऐड करना है. So second next is equal to first. That's what second next is equal to first. And then we have to move our second further also. Second will be moved to 5. And that's how it will continuously add all the elements one after another, one after another, one after another. And then at the last, once we reach second dot next is equal to null, we will stop there. I hope this was not that much tough. Right, guys? Did you guys understood? Everyone? I hope that was not much difficult. We just need to take one pointer temp to store the remaining elements. Then we need to add both arrays. Okay, so Hariharan doubts. Let's see what is his doubt. Sir, here head will go up to 1 2 3 4 5 6 7 or only 1 2 3? Only 1 2 3, because we have already changed it, right? While reversing, while we are doing the reversing, at that time we have already changed it, right? You see this line? Where is that? Reorder list. Yeah, this line, you see this line, middle dot next is equal to reverse. We already like broken the connection. We already updated our next here, right? Middle dot next is equal to reverse. When we were doing this thing, at that time we have already changed the our head. So the head would be only 1 2 3. All the remaining elements will be in the reverse. No. It has broken already. While we are doing the reverse, we have already broken with that. 1 2 3 is only in the head, and the remaining element in the reverse pointer. So let's code it. Let's code it, guys, quickly. So we have here first, we have second. Let's code it. So while what we did, second dot next is not equal to null. जब तक ये नहीं है, you have to do the operations. And we have taken one more temp just for storing the remaining element while we are doing the operations on that. So temp is equal to null. The first thing, temp is equal to first dot next, all the element of first except the first element, which would be 1. Where is that? Oh, I deleted it. Okay. I think somehow I deleted the one note. Okay. So temp is equal to first dot next. So it means first element, right? This one. Yeah, the first element. So all the next element would be pointed out to temp 2, 3. Correct? Now, after that, once we did that, so now first dot next, we can update the first dot next. First dot next is equal to second, the first element of second. Second list is there. Now we need to move our first to further for the next iteration. So now our first would be temp. This would be for first. Now let's do the same for second also. So temp is equal to second dot next. Now all the next element of second would be saved in temp. Correct? Now add the second element of first, which was this 2, right? Add the second element of first to the first element in second. So now we will do second dot next is equal to first. See, this is all visualization, guys. I'm not doing anything. I didn't remember anything. And I am expecting the same for you from you guys also. You do not need to remember anything. And then we have updated second equal to temp. Whatever we have done here, how the visualization is happening here, we have done the similar thing here. And let me run this code. Let me return now. Because now our head has been updated. So now return this dot head. Let's see if this is running or not. You can see 1, 4, 2, 3. Let's submit it. Let's see if any edge cases are failing or anything like that. Yeah, it's working good. Okay. Let me see if you guys have any doubts. Not understood the second dot next is not equal to null. Okay. Look at this is our second linked list. 7654. It has, you can see, more elements, right? 7654. So and 4 and null. So we are going to stop once we get the second list now next is equal to null. Second dot next is equal to null, because you can see in this linked list we are traversing from there. Always you can see in the odd scenarios this one is going to have more nodes, right? And let's look into the even scenarios also. In even scenarios, yeah, even in even scenarios both will have same nodes, but in the odd scenarios it is going to have more nodes. So that's why the reverse linked list, the second half of linked list is going to have the more nodes. So that's why second dot next is equal to null. Second dot next is not equal to null. Otherwise 4 we cannot take it, right? We can take 765. If you will do here, so null will be here, right? The first dot next is equal to null. So 4 will not come there. Correct? You can see in the odd scenario, only 3 elements will be traversed. If you will do the first dot next is equal to next is not equal to null, then only 3 elements will be traversed. But where second dot next is equal to null, so the last element will also be traversed. Understood? Yes, after 3, 5, first we will go to null and second go to 4. After 3 and 5, after 3 and 5, yeah, after 3 and 5, first we'll go to null. Yes, first we'll go to null and second go to 4. Yes, the first will go to null and second will go to 4. And once the second will go to 4, we will do second dot next is not equal to null. We'll stop there. Then why first null is not printed? Then why first null is not printed? 1 minute. Which line you are talking about? First null? First null is not printed. Which one? Then why first null is not printed? Oh, okay. 1 minute. Yes, after 3, 5. About the first pointer. Okay. Okay. Let me check. Let me check what you're talking about. Let's check with this code. Okay. So see, guys, how we are moving. So first we are going into the first one, right? Then we are going to, so see, first we'll go into the 3, then we will go into the 5, and then we are updating our, see, last line is second is equal to temp, right? So now first we are moving here. At the end, we are moving first second. So now 3, 5, then moving our pointer to 4. Right? Then we are, you can see at the second is we are moving at the end. Once we have printed out, once we have added 3 and 5, once we added 3 and 5, you can see now we are moving our pointer to 4 in this line. Second is equal to temp, and then our second will be here. It will not go into the first one. Before going to first, it will already stop. Understood? Before going to first, you can see this line. Look at this line. Read this line. Second is equal to temp. See how? Let me show you again. So first, let me show you again. Let me print it again. 1, 2, 3. Everyone, just go through again. 7, 6, 5, 4. Right? So how we are starting? We are starting from here. First is here. Temp is here. Correct? So we have printed 1 and we printed 7 also. Because first dot next is equal to ये connection हमने पहले बनाया. So 1 7. Correct? Second it here. After that, what we did? The next step, we have moved our first. Moved our first to here. Correct? Now our first is here. Then we move into the second line here. We are coming to this place. You can see temp is equal to second dot next. So now this temp, who was earlier pointed to the first linked list, now this temp will be moved to this place. Second dot next. Correct? You can see second dot next is equal to first. And then second dot next is equal to first. So now first is here. So 2 will be added. So now 1 7 2. 2 is added here. Correct? Now we have moved our second further. This is the line important. Understood? This is the line important. Second, we have moved our second here. This is happening similar here in the 3 5 also. So let's see one by one. So now again, this is the first iteration complete. First, this is happening. All these things happen in one iteration only. Let's go into the next iteration. Let's look for next iteration. Now our temp will be this. Temp will be this because first next. Okay. Now in the 2 we will add the second next. We will add the second, which will be 6. Now we added 6. Right. Now this connection is, so this connection, after that this connection has made 2 say 6. Okay. Now we have updated our first again. Now our first is pointing to this part 3. Correct, guys? Now we'll come for the second part. This is still second iteration is going on. This is still second iteration is going on. Now change our temp. Take our temp here. Correct? Now after taking temp, second dot next is equal to first. So 6 will be moved to 3. This connection will make. Right? Second dot next is equal to 3. Okay. Now what? We have to move our second. We have to move our this one. We have to move our this pointer to this place. This place. Second. Correct? We have moved to here. 1 minute. Correct? Now our pointer is at this place with temp. Okay. Now we are checking again. Second dot next is not equal to null. Right? Second dot next, where was that? Yeah, this condition. Second dot next is not equal to null. So let's see. Second dot next is not equal to null. That's right. Right? Second dot next is not equal to null. So now we will again go into the first part. Right? Now first dot next is equal to null. So temp will be pointing out to null. Temp will be pointing out to null. Right, guys? Temp will be pointing out to null. Let's see. Now the first dot next is equal to second. So after 3, the 4 will come. 5 will come, sorry. After 3, this connection will be made. Right? So 5 will come here. Now let's see next. Now first is equal to temp. First is equal to temp. Now first will also be pointing out to null here. First will be pointing out to null here. Now let's move further. Temp is equal to second dot next. Temp is equal to second dot next. So now temp will be moving to the here. Now temp will be moving out to this place. Correct? Let's see. Okay. Now temp will be moving out to this place. And then what we are doing? Second dot next is equal to first. So second dot next is equal to first. Okay. So that's what you are saying, that null will come at this place, right? Second dot next is equal to first because into this iteration. I see. That's what you are saying, explain. That's what you are saying, right? Likit. That second dot next is equal to null. Okay, let's see. Let's see what we are missing here. Anything we are missing here? So let's just dry run it again. We might be missing something. So okay, so first is here. Okay, so first is here, this place. Okay, and then we are doing temp here. Okay, temp would be at the second place, correct? Okay, and then first dot next is equal to second, which would be 7, correct? And then first is equal to temp, then first is here, correct? Right? And then temp is equal to second dot next. Okay. Correct. Yeah, so second is equal to yeah. So now we are into second. So this would be our temp here, correct? Okay. And just revisiting one more time. Temp is equal to second dot next, right? So our temp is this place. Then second dot next is equal to first. So 7 2. That's correct. We are good till here, right? And then second is equal to temp, right? So second will also be here, correct? Second would be here, right? Now let's move further into the first loop where second dot next is not equal to null. So first is equal to first dot next. Okay, again temp will be moving here, correct? First dot next, and then yeah, so first dot next is equal to second. First dot next is equal to second. So 2 से 6 add हो गया, correct? That's also right. And then we move our first here also. We move our first here, correct? And then after that we come to the second part here, which would be temp would be moving here, correct? ठीक है? Temp is equal to second dot next हुआ, okay? And then second dot next is equal to first, which would be adding 3 here, correct? Okay, 3 is also added here, and then so yeah, so then we are coming back to yeah, so now this is here. Now we are coming into this part. So where temp will be moved here, right? Temp will be moved here, and second dot next is equal to first. So second dot next. Oh, right. We are still in the first dot next. So sorry. First dot next is equal to second. So 3 and 5. 3 has been added. Correct? Yeah, we were here. Sorry, we were here. So second dot next is equal to first, and then second will point out to here. Correct? This line. Yeah, this will be pointing out to here, correct? Yes, okay. Then we will go further again, and then first dot next is equal to null. So temp will be pointing out to null, and first dot next is equal to second. So 3 dot next is equal to 5. So this is also correct. And first is equal to temp, okay. First is equal to temp, which is null, right? Yeah, right, which is null. And then temp is equal to second dot next, which would be this 4. Okay, temp would be here, and second dot next is equal to first. Yeah, right. Here it should come. Here it should point null, right? Okay, if it is pointing to null, let's see if it is pointing to null. Okay, if it is pointing to null, then what? Then second is equal to temp. So now second will be here, correct? Second would be here in this place, and then second dot next is equal to is not equal to null. which is here, second dot next is equal to null. So our condition should stop and we should get only 5 null. 4 should be missing. Our condition. What do you guys suggesting? What we are doing wrong? Something we are doing wrong, it seems like. I think we must do middle plus 1 so that 4 will be in first. Okay. That's the scenario. But no, wait. See, wait 1 minute. We are missing something in the logic, because see, in our output, 3 is coming at the end. You can see 3 is coming. So let's see. Let's first print what is first and second it is giving us. Okay, let's quickly see first and second what is giving us. Okay. Okay, so in the first 1, 2, 3 is coming. In the second 4, 3 is coming. Okay, so they are taking actually the last element also. 1 minute. Let's see in the reverse what is happening. In the reverse, what we are doing. 1 minute. So in the reverse, we have taken the slow one. Okay, and slow will start from 3. Oh, this is the even scenario, right? Let's look for the odd scenario, right? This is the even scenario. But yeah, in even scenario, they can take even scenario also. Yeah, I think in even scenario, they are taking it, right? So let's see quickly what is happening here in the slow dot next, okay, and fast dot next. So it will stop at slow will stop at, I think 3. Slow will stop at 3, okay, right? And then then what will happen? Let n is equal to middle dot next, okay, middle dot next, and middle dot next is equal to null. Okay, middle dot next is equal to reverse. See guys, see, that's what I think. One thing we missed, we are not removing this 4. Actually, you can see we are doing middle dot next is equal to reverse. It means middle dot next will become null. Middle dot next will become null here. So that means this middle element is not going from the first list. From the head, you can see we are doing middle dot next is equal to reverse. It means from the first element, this middle dot next, this 4 is still there. So that's right. That's right. This 4, this last element 4 is still there. This last element is 4 is still there. That's why this logic is working. Understood? We missed that. We missed that actually the first part of that where we have taken the middle dot next is equal to revenge, because at that time we are already taking the middle element and then we are making the next element null. So that's why this, see, while I'm saying this, when we get the 1, 2, 3, so we are doing this thing after 4. So see what is happening. Let me tell you in the reverse what is happening. 1, 2, 3, 4, 5, 6, 7 and null. What happened? Slow has come to this place, right? Slow has come to this place, right guys? Slow has come to this place. So what we did in the while loop, what we did, while, what was the condition? While fast. For the middle, what was the condition? Let's check quickly. What was the middle condition? Yeah, while we have that slow element, and you can see the first line which we taken, let n is equal to slow dot next, all the next element of this one, and then when we did slow dot next is equal to null. So when we did this line, then only 1, 2, 3, 4 is still there. So after that, all becomes null for first list. 1, 2, 3, 4, and then it will become null. So that's why 4 is still there in the first list. And in the reverse list, 4 is also there. In the reverse list, 4 is also there because we are doing the operation or slow on the 4 only. 4 dot null. We are doing the operation on this 4. Then we are doing 5 4 null like this 5 4 null. Then 6 5 4. Then 7 6 5 4 null. That's what. So 4 is at both places, in the first list also and in the second list also. I hope that clears. Yeah, that's right, Likit. That's right. You got it correctly. Totally agree. Totally right. So yeah, everyone understood this? Do you want me to repeat anything? Let me see first. Let me post this code. Let me see first I had this code or not. Oh yeah, I have under the rotate function. You can see this is the rotate function which we had. You guys can look into this one. I will push these changes. Already I think they are in the GitHub repo. Everyone understood, or you guys want me to repeat it? Sir, confused in the 4 at both place. Okay, sure, no problem. So did you understood this one? First thing, how this 4 as in the first linked list, how the 4 is coming? Yes, in the first linked list you got the how the 4 is coming, correct? Because we did the this. So in the second linked list, which is reverse linked list, how we were doing the reverse, linked list? You remember we have taken one pointer which was reverse, right? Let's take the name correctly, which was reverse, right? And then we started our loop while slow, correct? And we taken all the remaining element of that slow dot next. अब देखो ये पूरा एरे था ना, पहले हमारे पास पूरा एरे था 1 2 3 4 5 6 7 and what is that? Null, right? In this whole linked list, head was here and slow was here, correct guys? Slow was here. Then what we did, n is equal to slow dot next. So n is pointing out this place, this whole part, this whole point, n is pointing out right now. 5 6 7 null. That's how we do the reverse. Then what next line? What was the next line? Slow dot next is equal to null. जैसे हमने ये लाइन करी slow dot next is equal to reverse, then the slow dot next, इसका जो भी next था वो सब null हो गया. So now the main linked list 1 2 3 4 has become null. Now our head is pointing out to this linked list. Okay, right? This is the linked list right now, and slow is still at the 4. Slow is still at this element. And now then what we did, slow dot next is equal to null. Then what was the next line? We did it here. Then we make our yeah. What was the next thing we did here? Then we made our reverse. Reverse also is equal to slow. Reverse is equal to slow. So now reverse has also become here. Reverse has also come here. And then we did slow is equal to n dot, slow is equal to n. This n part, the whole part. Now slow has moved from 4 to this element 5. You can see now reverse is pointing out to 4. Now reverse is pointing out to 4. So that's what, this is the first linked list. Now this is the first linked list. And now you can see in the second linked list, now it's the reverse. It's the reverse. It's the reverse keyword who has also pointing out right now to 4. Now it will start 4. Then how we do the reversing? We take the next element and add it before it. So 5, 6 and 7. So that's why in the second linked list we were also getting the 4. You can see that's why reverse. That's how we do the reverse, right? From that element we start adding in the previous element. So 4 to 5, 5 to 6, 6 to 7. Understood, Hariharan? Actually, 4 should go to second one, right? How come it's yeah? I told you, right? This thing with this line, right? Slow dot next is equal to null. I showed you, right? This is the slow right here. Once we did slow dot next equal to null, I can see 1 2 3 4 null, because we are doing next of this element, not You can see slow dot next. That's what the next of that element is updating it to null, not that element. Understood, Hariharan? Not that element. Oh, no problem. So Deepak has shared one doubt. Let's see his doubt. Not getting what's wrong. So let's see his code. Slow is equal to head. Let's fast equal to head. Okay, slow is equal to next slow, while fast is not equal to null. Fast dot next now is not equal to null. Okay. Mid, okay, we got the mid, we got the reverse. Let n is equal to mid dot next. Mid dot next. Mid dot next is equal to reverse. Yes, that's right. Reverse is equal to mid is equal to n. Correct. Let first is equal to head. Okay, first is equal to head, correct. Second is equal to reverse, totally right. While second dot next is not equal to null. Okay, good. Temp is equal to first dot next is equal to temp, first is equal to temp is equal to second. ये गलत है. Temp में second नहीं रखना है, temp में second के next रखना है. So that's what the problem here, Deepak. Okay, correct your code. Temp में second नहीं, second के next. Understood? Okay, Likhit is saying why reverse is equal to slow. Why reverse is equal to slow. Why reverse is equal to slow. हाँ, क्योंकि हम yeah, this line, right? Why reverse is equal to slow. This one you are asking, right? So see, first what we did, slow dot next is equal to null. So slow was 4 and we made it as a null. Earlier reverse was null. So now we want to make reverse here. Now we want to make this whole list our reverse, because हम क्या कर रहे हैं, हम जो भी नया एलिमेंट आ रहा है, we are adding this reverse there. The code is like this, right? This code is like this. Slow dot next is equal to reverse. So first, whatever the new element is coming, we are just adding the reverse into that. So that's why whatever the next element will come, like 5 will come. So 5 dot next is equal to reverse. So 4. अब हम क्या करेंगे, हमारा स्लो अभी 4 पे है, अब हम स्लो को रिवर्स बना देंगे. So now reverse will be there, and we will move our slow to 6. क्योंकि हमें नेक्स्ट एलिमेंट लेना है. दैट्स व्हाई वी आर डूइंग द रिवर्स इक्वल टू स्लो, बिकॉज दिस इज द ऑल प्रीवियस एलिमेंट व्हिच हैज बीन ट्रैक्ड. सो दैट्स व्हाट वी आर डूइंग इट. अंडरस्टूड लिखित? व्हाई वी डिड द रिवर्स इक्वल टू स्लो? अंडरस्टूड? या. Okay, so what about others? What about Hariharan? Did you understood now, Hariharan? Okay. What about Arad? Where you feel where you got lost? You have already understood the reverse part. You have already understood the middle element. What about where you got lost? What about others? Ankit, Vishal. I think Vishal has already done it. Yes, definitely. Nilanjan. What about Nilanjan? Nilanjan, I'm not seeing any of your reply. And I think, guys, you guys are confused in one more thing. I think let me clear that one also. Okay. Let me clear that one also. Okay. So let's see. Head have this object value 5. Next. It again has one object. That's how the linked list is written, right? 4. Next. It again has one object value 6, and next. Now this next is null. Okay, guys, that's how our linked list in the memory it looks like this. If I visualize it like this, it looks like this: 5, 4, 6, and then null, and head is here. That's how this looks like in program in the memory. That's how this looks like in memory. Everyone agrees? Everyone understood this thing? Everyone understood this thing? That's how it looks in the memory. Okay, agree? Everyone? Okay. Now see, when we do this thing, like let current is equal to head. Correct? तो ये same value आती है इसके पास. So current will also have the same. Now current will also be same. Okay? current will also be same. Okay, everyone agrees? Current will also be same. Then what we do? Current is equal to current dot next. Current is equal to current dot next. That's what we do, guys, right? Current is equal to current dot next. That's what we do, right? Current is equal to current dot next. So we are not moving our head now. We are just updating our current. So now our current will be having the second part, which is this part, this whole object. This whole object will be going to the current part. So current is equal to val is equal to 4, next is equal to val dot 6, and next is equal to null. Here our current is. We have not changed, our head is still at the same place. If you will print head and current, you will see different values. Understood? First you understood this part. If you will print current and head, you will see the different values now. It's not same. We are not changing head. Okay? Understood, guys? First, let me know, did you guys understood these two things? Once we did current is equal to current dot next, it's not equal to head. You see, it's not equal to head. Current has moved to another place. Current is now pointing out to this part of memory. Current has moved to this part. Current has moved to here. In visualization, it looks like this. Current has moved to this part. Current does not have any reference to the previous one. Everyone understood? Assignment won't get affected by pass-by reference. Yes, assignment won't get affected. That's totally right. But guys, if I do current dot next is equal to something else like well, or simply current dot next is equal to 5. Current dot next is equal to 5. So it will change our head also, because now see, this is another scenario. I'm just now updating the values directly. So now what will do it? What will it do? It will change this whole value. So now once we do this line, so now this will look like this. I'm just taking the same from the starting. So val 5 and next is equal to also 5. So head will also change. Head will also change here. Just ignore this line first. We have not moved. Just ignore this line, guys. We have not moved to, no, not whole line. Just ignore this line. Let me raise it. Yeah. If we did these 3 lines, if we do these 3 lines, current is equal to head, current dot next is equal to 5. It will change our head also. It will change our head also. That's what I want to explain to you guys. When we are assigning, so you can see here we were assigning, this is difference, current dot next. This is different than this thing. That's what you need to understand in the JavaScript. This is different. These both operations are different. When you do these type of operation, current dot next, it will change head also. It will change head also. But when you are doing once you are doing current is equal to, so you are simply changing whole memory. But once you do current dot next, it will change. See, this will be very much like I have one screenshot for that also, which will explain you nicely. Can you guys see my screen? This is not little bit clear, but can you guys see my screen? That's how the JavaScript work. Okay, you can see we have one object here, ID1 name, and we are passing pass by value, and we are passing that object here. You can see once I did reference dot ID, so you can see in the first step it is changing the original object. It is changing the original object, reference dot ID. But once I did reference equal to, it has created a separate memory. When I did reference equal to, it has created a separate memory. You can see it has created a separate memory. It is not going to update anything in this one. Now reference has been changed. Once I do reference equal to earlier reference and head, similar thing, guys. That's what we are doing here also. Earlier, till this line, let current is equal to head. Till this line, head and current was pointing out to same one. Till this line, current and head was pointing out to same memory. Current and head was pointing out to same memory, this memory. But once I did current is equal to current dot next, now current is not pointing the same memory which head is pointing out. So that's what, once you will understand this difference, then you can easily understand the the code which is which that the code, how the linked list is also moving. In the first line we are not updating the property, but we are doing it in the second line. If you are saying this is the one first line, this is the second line, these both are, yes, in the first line we are not changing any properties. We are assigning different memory now. Earlier we have provided head. Earlier, very simple, guys. This is head. Head is pointing out to 4. This is 3, 2. So once we did current is equal to head. So now current and head are pointing out to same place. Once I did current is equal to head dot next or current is equal to next, current dot next. अब current की memory change हो गई है. Current will be pointing out to this one. But still head is at similar place. But अगर हम करते इसकी जगह, if we do like this, current is equal to head, and then if we do current dot next is equal to current dot next. If we do this, head will also move here because करंट का जो नेक्स्ट है उसको तुमने अपडेट कर दिया है और उसको करंट डॉट नेक्स्ट बना दिया है. सो नाउ करंट और हेड बोथ विल मूव हियर. नाउ दिस एलिमेंट इज लॉस्ट. नाउ दिस एलिमेंट इज लॉस्ट because now you have updated the property of this element only. So means head, you have updated the head only. It means you have updated this part. This whole next has, you have updated it now. So that's why, guys, you have to understand this thing. When you are assigning something in current or when you are changing the property, when you are changing the property, you are going to change the original one also. But when you are assigning something else, you have created a new memory. That's what I want to explain you guys. If we do current dot next, then it will change head as well. Yes, if you will change the property of that current, it will definitely change simpler. Similar like this, you see. If I take one object here, let temp is equal to name is equal to arpe, age is equal to 25, and if we do that and if we print it, so you can see temp is coming here. Now if we take another variable, let current is equal to temp. अभी तुम करंट में कुछ भी चेंज करोगे, करंट डॉट age is equal to 23, it will change the original one also. You see the temp, see age has become 23. But if you do this, let current is equal to a new object like this, or simple temp dot age. Now you can see current is just pointing out 23. Now current memory has been changed. Now whatever you will do the changes in the current, it will not impact the previous one. Let's say, see, let current, let's create a new object. Test 4. Now you can see whatever you are changing in the current, it will not change into temp. Temp is still there. See, temp name age. So that's what I'm trying to explain you. When you are, see, first time when you assign current is equal to temp, if you are trying to like change any of the property of with the help of current, it will also change temp. That's what happening there also. This temp is head there. So if you will change any of the property of that current, so it will change your head also. But if you are assigning the memories only, like next, temp dot next, then you are simply just changing the current there. You're not changing. Did you guys understood, or you want better example? Or you want me to create a good example also? Did you understand this thing? Everyone got it right? Because this is this is very important to understand. Then only you can understand how the linked list like traversal is working. Okay. So I think now we have like left some more questions. So before that, let me just explain some of the things to you. So I want you guys to solve this question. Find cycle in linked list. This is the next question. I will just explain the logic. I will explain the logic very quickly for two problems. For this problem and for this problem also. Find intersection. And I want you guys to do this. Okay. Let me explain the find cycle in linked list. So this will be approach would be same, guys. Find cycle in linked list. Approach is same. So right, see. So if okay, this is the linked list like 1, 2, 3, 4, 5, 6, 7, 8, and 9. You can understand these are how many nodes? 4, 5, 6, 7, 8. 9 nodes are there. Correct, guys? 9 nodes are there. Correct. Now you need to use the same approach, fast and slow wala. Fast and slow. So you can see, and you can start like because see, और जहां पे भी fast slow को cross कर जाए, wherever fast is equal to slow, you have to stop there. You have to stop there. So what we need to do here now, we have to start our slow from here, and we have to start our fast from here. Otherwise, at the first index only fast is equal to slow. Our condition will fail. That's why we will increase our fast one more step. Okay, one more step ahead. So now you can see. Let's move it. Now let's move them. So one will be moving here. The slower one, the faster one will be moving 4. Correct, guys? Let's move one more. Here, let's move our faster to 6. Correct? Let's move 3 to 4. Let's move our faster to 6 to 8. Correct? Let's move our 4 to 5. Let's move from 8 to 4. 2 time like 2 time faster, right? So 4 is here. Oh, we have made this wrong. Yeah, this should be green, right? 8 to 4. Correct? Now let's move 5 to 6. And now you can see green one has also come into the 4 to 6. You see, here your condition will fail. The condition will be fast is not equal to slow. Tab tak chalo. Here your condition will fail, and you will say that you will simply return yes, it's true. Right, guys? That's what you need to do. Wherever your fast and slow clashed, you have to return that true from there. That yes, in this linked list, cycle exists. Everyone understood? Everyone understood the logic behind that? No, no, it's single linked list only. It's single linked list, and in some way, somewhere in the single linked list, somehow the middle elements got traversed, like got the list here. Like it will look like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 9 next has become 4. So you have to find out, you have to detect, you will provided the head, and you have to detect that the linked list has any cycle or not. And how will you find it out? With the same approach, fast and slow. You will start traversing, and whenever your fast and slow got like what would we say? They have passed each other, or they got like एक बार भी उनकी टक्कर हुई. So that means like in हिंदी भी से they got टक्कर हुई उनकी. तो जहां पे भी उन्होंने क्लैश किया, wherever they got clashed, it means we have a cycle. We have a cycle in the linked list. We need to traverse it only in this problem. We need to traverse it only in this problem. I didn't understand this thing. What do you mean by that, Anand? Everyone understood? The logic behind the finding a cycle in the linked list. Everyone understood? How can we find a cycle in a linked list? Single linked list. If somebody has provided a single linked list to you, you have to find you have to find if there is any cycle exists in the linked list or not. You can find it through that way. Traverse, and if class slow and fast, then return to. Yes. And if you are traversing, if you are so okay, you guys tell me, if in your linked list there is no cycle, what would be the condition for that? So your fast should be null, and fast dot next is not equal to null. अगर the same odd even वाली condition, अगर in your linked list if there is no cycle, then what is the condition for that? You have to check this only. Fast is equal to null, and or here I think we can go for or also, or fast dot next is equal to null. अगर ये वाली कंडीशन पहले हो जाए, so you have to return false, because it means there is no cycle in the linked list. It means there is no cycle in the linked list. If your fast reached to null, or your fast dot next reaches to null, it means there is no cycle in the linked list. But if it is not the case, if this is the case where fast has reached to or fast has got clashed with slow, you have to return true. Understood, Anand? Two scenarios only, right? In the single linked list, cycle exists or not exist. Once, so cycle कब exist करेगी? Cycle will only exist when slow and fast has been clashed. अगर cycle नहीं exist करेगी, that would be when fast will be reaching to null, or fast dot next is reaching to null. Understood, everyone? What about others? Deepak, Anand, Likhit, Arad, everyone understood? Easy, right? We have already done this, right? Earlier, faster and slower one. Just need to change the conditions. Correct? Let's look into the last question also. That is also easy, guys. And you can find this like in the let me provide you. I have the question. This is like easy question. Detect loop. Yeah. I will provide you this URL. You can check this one. You can check this URL and easily try to do that. Okay. And let's quickly talk about the next one also. Last one. Or let's stop it here. We can talk about it later also. No problem. Okay. So yeah, that's all for today, guys. I hope you guys have enjoyed it, and you guys have seen some of the like different approaches to start any problem. I hope you guys learned a little bit today. And see, in similar way, whatever you have learned is going to use in many problems. The fast and slow one and the other stuffs, whatever we have seen, it is going to use in many places. Reverse the linked list is very common problem. Rotate a linked list, somebody is asking in interviews also. Okay, so in tomorrow's revision session, so first we will start these problems, and then we will see some of the assignment problem also. Okay, so I want first to everyone to solve this problem actually first, the detector cycle, because the next question after that, the fourth question is starting point of cycle. This is also very interesting. Once we detected a cycle, we need to tell what is the first element in the linked list from where the cycle has started. First, you have to find out see in this diagram, you can see from 4 the cycle has started. From 4 the cycle has started. So we need to give the 4 there. That is the next problem. That is little bit hard, but yeah, we'll talk about it. Okay, guys. So yeah, that's all from today. Let's meet tomorrow. and then we will continue from there. Okay, guys, have a good night. Bye bye.